Hello Ravencoin lovers and welcome to Raven Rebels video about miner rewards or block rewards. In this little video we will grab a cup of coffee, black coffee, no milk, no sugar, and we will use JavaScript to scan the Ravencoin blockchain and calculate miner rewards. And what are we talking about when we say miner rewards? Well, I mean that the block reward, each time a block is added to the blockchain, it's added by a miner, and that miner has confirmed the transactions in this block. So the miner gets rewarded. First off, it gets a reward, the block reward for the actual block. In Ravencoin right now, it's 2,500 Ravencoins is the reward for mining a block. But that's not it. The miner will also get all the transaction fees, all the fees for all the transactions that are part of this block. So therefore, this reward is different for each block. So let's create a script that scans Ravencoin blockchain since the halving and check what the miner has gotten. So first off, let's look at a Raven block explorer. There are many, Google them. And we can see that here we have the latest block, only has one transaction. And I assume that means that there were no other transactions. The only transaction that is part of this block is the reward that goes to the miner. So if we click on this one, we can see that it has one transaction of exactly 2,500 Raven going to the miner pool. And since there are no other transactions, it's only the block reward. But let's go back and see if we have, here we have a couple of 2-3 minutes ago, we had another block which had 4 transactions. And my understanding is that always the first transaction is always the transaction that goes to the miner with the rewards. So here you see that the miner received 2,500 and something, 2 Raven. And there are some, and this is the transactions that the user have done. So now let's create a script that looks for all the blocks since the halving, like half a year ago, and lists blocks by miner rewards, which block gave the miners the most Ravencoins. To do this, we will use this at Raven Rebels Ravencoin RPC. It's a helper package in Node, npm, that makes it super easy to communicate with the Ravencoin wallet. And we have Raven Core. This is our source of truth. This is our local wallet. And we have set this one up, open configuration. We have set it up in server mode. And we also have all those fancy indexing on. So our wallet has information about it indexes how much we spend and all the owners of all the assets and stuff. So this really helps if you need to grab more knowledge or more information from the blockchain. So, and for this demo, we have changed the username and password to something very silly. So let's fire up a command prompt. We are on Windows, should be the same whatever operating system you have. And let's create a directory called, let's only call it, we call it rewards. So we go into rewards and here we have an empty directory. So the first thing we do is to initialize an empty package. There we go. npm init -y. And we write code followed by dot, which means open Visual Code in this current directory. So we are using Visual Code from Microsoft open source free editor. It's very nice. This is our empty project. And from here, we can make life simple by opening the terminal. So we are in here. The first thing we do is to install this Ravencoin RPC from Raven Rebels. Ta-da! And now we can go to package.json, describes our package, this project, and we see that we are now dependent on this. We have a dependency. We are using this library. And also to get up running quickly, we copy the example code from npm. So this one gets the utility function get RPC from Ravencoin RPC. And we need our username and password and the local URL, and then we can do stuff. So let's just check that this works. We copy the username and password. And this example asks for asset data for token Elvis. Here we go. Now we have information about Elvis. So now we have a script that can connect to our wallet. Nice. That was quick. And I can recommend you to check out this Ravencoin RPC on npm. And of course, just click to go to GitHub. It's open source, so you can fork it or change it, whatever you like. And if you check out the index.ts TypeScript file, you can see that there's not so much code. We are basically just doing some networking stuff, and we add error handling to this one. So now we have a script that prints out Elvis, but we are not interested in that. We are interested in blocks, right? So let's create an async function. We call it work. We make it async so we can await stuff. That makes handling asynchronous stuff in a synchronous way easy. Since we are in async, we can say, let's ask for the current hash of the current block. RPC. So we call the RPC method and we send in, this is a nice little guy. This method here, it's just a helper to make for you to get a list of all the stuff you can do in Ravencoin. Get best block hash. And we need to send in params that are empty. So now we should have, if we only run this code, we should get the hash of the current block, and we do. So now the next step, we have the block. Let's get the actual block. Get block perhaps, yeah. And we also have this nice type ahead here, so it tells us we have managed to inject the documentation from the wallet, so we can see that we are supposed to call get block with the argument or parameter block hash, and also verbosity. So we say get block, and the params should be hash followed by 1, because verbosity is supposed to be 0 or 1. So we say params, and we print out the block. Here we go. Here we have information about the current block, so we can see that nice, we have the transactions here. And what we do now? Well, now we have the block. What we need to, because we will go back many times to look at how a block looks. So let's save this one as a JSON file so we have it. So let's say, let's require fs file system. So we can say, let's first off convert the block to JSON. We do that by calling json.stringify, and you can add null and 4 to that call. That will indent the JSON file so it's readable. And we say fs write file sync, and we save it as demo block JSON. Now when we run the code, we expect a new file popping up here with the block. Good, we will save this. It will help us during the development. We can just go to demoblock.json and see what the block looks like. Nice. So now let's say we need another function to say that to get the we need to get the rewards for this block, right? And we assume that it's the first transaction that goes to the miner. So we just have to check out what this transaction contains. The output of these transactions, we suppose, is the total rewards for the miner. So then we say, so we assume that, okay, so if we calculate, let's do this, reward, get rewards. So we say console.log rewards for block hash. So now we say -1 because it's a wait, because we have not implemented yet. Okay, so we know that we are going to go for tx, the transactions, and we're going to get the first transaction. So let's do that. Const id equals block tx, the first transaction. And we then need to get the actual transaction. Ask the wallet for the transaction. So we say RPC methods get raw. I know it is this one. Get raw transaction. We click Control space to get this preview up. And we say that, okay, so we call get transaction with the ID and then argument for verbosity. It's supposed to be true in this case if it's verbose, otherwise false. So we send in the argument ID followed by true. Now we expect that we get stuff about the transaction back. Let's do the same thing. Let's save this one to file. Const JSON equals JSON stringify transaction null 4. And we write that to file, write file sync. So now we have a, now when we run this code, we expect it to create a new file called demo transactions JSON, and now we can save this one because now we know what transactions look like. We say that there, it has a v out with some value stuff. So since we know that it has this v, we only have to go over each item in v and append the value to the rewards. So we think that, okay, let rewards equals 0. And then we start transaction v out map for each. That means for each in v out, get the value. Rewards equals rewards plus t dot value. So we hope this is the correct thing. Now we say that it says that the fee for this block was 2,500 and some tiny little stuff. Let's see what the Block Explorer says. Yeah, it's the same thing here. It says that 2,500 013 2,500 nice. So now we can calculate the rewards for the current block. Nice, but we want to scan all the blocks, right? And we can see in how here, previous block hash. Each block contains a pointer to the previous block, a reference. So this is what we need. So we need to do this multiple times. So we do a while true loop, which we will break with the word break. And we move this stuff here. And let's do this. Let's set a counter And when this counter is, if counter larger than 10, break. So so now it runs multiple times. Nice, but we want it to, so we know that first hash is the current hash, and then we get the block and we calculate the block rewards. When this is done, we should set hash to block dot previous block hash. So the next time we loop, we will now get the previous block and the previous block, so on. So now if we run this one, we see that we get different blocks. That's nice. So now it prints out the block reward for each block. But as we know that there's one block per minute, and there's 60 minutes in an hour. So when you start, let's say 60 minutes times 24 means 1,440 blocks per day, and that is 500,000 in a year. So I mean, we can't just log out stuff, so we need to build this up in memory so we can sort it and print out the most expensive blocks, the highest block rewards. That is what we need to do. So what do we do now? Well, we need to save this information between for each block, and we also don't want to look, we only want to check a block once. Next time we run the script, we don't need to check that same block again. So let's create the concept of a super simple database. Let's call it DB or cache or whatever, but it's just an empty JSON file. And then we say that, okay, now we have, when we are here at line 37, we have the block rewards, the rewards for this block. So let's do this. Let's do db hash equals, let's create a new object which contains rewards, it contains hash, and it should contain the previous hash, and I guess we want to have the time as well, the time when this block was added. So for each iteration of this loop, we add this object to our database object, and let's do this. .db require, we can require the JSON file, and we add this in memory, and when we are done looping, we should save this one to the database file. So now when we run the file, we expect it to write everything to this DB. It does. Looky, looky. Now we have a file that says this is the hash, and the key is the hash, and also the rewards. Nice. And then we know that when we check the block, we can then in this loop say, okay, let's take the block from our little so-called database, and only if the block is null, if not block, then. So now we only process the block if we need to. Never more than once. So, and we don't need to calculate the rewards more than once, and we only need to add it to the database if we get it from the blockchain. Otherwise we just continue. So now the code is super fast. Let's do this. Block rewards. So now it will be like because it's from memory. Nice. You have some undefined. Why do we have some undefined? Let's empty our database. Let's run the code. Oh. Block.rewards. Let's run this again and see. Because the first time, okay, so we add the rewards to the block, of course, but if we get blocks, because we might, we got it from the blockchain, it doesn't have a block rewards property. So we can run it now, and now it works. Nice. So now we only scan it if we need to, and let's say that we can count how many. And we only want to increase the counter if we go to the blockchain, right? So let's set this one so that, let's say it's 1040, or make it 60 times 24. When we run this code, we will go 60 because it's 60 minutes in an hour, 24 hours per day. So let's calculate the blocks for 1 day. And this should of course be like this. So if the counter is more than max is all the blocks for a day, and we only increase our counter if we need to go to the blockchain. We exclude the cached stuff when we calculate that stuff. So now if we run this, we are printing out to the console. That is very slow. Always remember that. Printing out to the console is slow. That makes your script slow. So let's run this, and it will scan all the blocks for 1 day. So now our so-called database contains a truckload of stuff. So that's nice. Now we have code that can go back and look for stuff. And perhaps we should be like this, that if we go to the we can say like this. If instead of doing a counter, what we can do is say we can check the block height, because we know that block halving Ravencoin, that Ravencoin had a halving at the block 2,100,000. So we can instead say that if the block height is less than 2,100,000 when the halving was, we can break. So let's do that. Let's say that if block height is less than 2. And we say break at the halving. So now we're breaking at the halving, right? Nice. And this will run for a very, very long time. So perhaps each we want to print something out of the console while this one is working. So perhaps we can say what was that? If counter modulus 1000 equals 0, let's create a date object and say date hash. So now for each 1000 block we will print to the console which date we are processing at. And we can also save to the database each 1000 times, because in that case now we can interrupt the script if it's going, if it takes too long. We can do that, it's okay. Because we are from time to time saving it each 1000, for each 1000 block we save it. So this one should be able to, and we don't have a counter. Let's see, we expect this to soon print out that it's processing. Yes, you see that. Now it's processing the 9th of July, 8th of July. So it's working and working and working. And while this one is working, or we can interrupt this one now, and it's nice since we save from time to time, we still have saved the last calculations to our little database. Now create a top list. The top list should just print out the most expensive blocks where the miners have received the highest rewards. So what do we do now? We get the database and we get blocks is, because we know the database is key value, key value, key value, and we only want the values. So we get the blocks are all the values in this db.json file. Now we have the blocks and we want to sort them by rewards. So we do a function called sorty that we will use to sort like this. And then we want to print out most expensive is, so we want the first block. When we have sorted the blocks, we want the first one to be the most expensive. And sorted takes 2 arguments and we compare the arguments. So we say if a.rewards are less than b.rewards, return 1. If a.rewards are higher than b.rewards, return -1. Otherwise return 0. So we hope that this will so we expect this to be given that we have scanned a couple of days, we see that there was actually a block where the miner got 11 Raven extra. So let's check this block hash on the block explorer. So we see it has 13 transactions, so lots of stuff going on in this transaction. Lots of small transactions, transactions with lots of output. So that's nice. And then perhaps we should we can do it from the command line. We can say node index. So it will, in the background here, start checking for blocks. And since this one is working here, we can now run this one and we should get like a different result. Now it's, now it's up to 2,972. Perhaps we want to say new date. So we can then say function print block constant date equals new date block dot time times 1000. And then we say we want block 0, top 1. Now we print out the top 5. So this one should print out the top like this. Now we have a top list, and we can see that at the end of June, we see that there was one block that gave the miner 1,000 Raven extra. That is a lot. The first transaction was 3,058. And that is what our code says as well. Nice. And this one is working hard in the background. We are now at the beginning of June. So this will work in the background, and it's caching everything. So now we were able to create a script that could print out the blocks that gave the highest or biggest rewards to the miners using JavaScript. And as you see, it's kind of easy to use this Raven Rebels Ravencoin RPC. We are working hard to create as many utility packages for NPM for Ravencoin developers as possible. So we have right now we have Ravencoin RPC, which we use now to use the RPC function. We have Ravencoin message, which helps you to sign and to verify messages in Ravencoin from JavaScript. And we have Ravencoin key, which generates private and public keys using mnemonic phrases, your 12 words. And we hope we will publish more utility NPM packages to make life easier for Ravencoin developers. I really hope you liked this video. And if you did, please give it a like, please give it a comment, share it. Ravencoin needs more adoption, so the more noise we make, the more people will be able to find this beautiful little blockchain. So have a nice day, everyone. Thanks for watching.